Welcome to the lecture series of probability and random processes. Today we are going to discuss about continuous random variable. Look at the definition. A random variable capital X which takes all possible values in a given interval is called a continuous random variable. So continuous random variable we have to keep in your mind in a given interval. Okay, given interval is called a continuous random variable. Example: age, height, weight, etc. So the next one is probability density function. If there is a function y equal to f of x such that limit del x tend to 0, p of x less than capital X less than x plus del x whole divided by del x which is equal to f of x, then this function f of x is termed as the probability density function or simply density function of the random variable capital X. It is also called the frequency function, distribution density or the probability density. The curve y equal to f of x is called probability curve or distribution curve. So what is this probability density function means? Probability density function is only for continuous random variable. So this f of x is denoted as probability density function. This probability density function always we have to consider as y equal to f of x. Here x plus del x is nothing but a small increment in the value of x. So when we are allowing the del x tend to 0 which is equal to f of x, this f of x is termed as p.d.f or probability density function. Always we have to keep in our mind that y equal to f of x is a probability curve under this probability and random processes. So y equal to f of x is called probability distribution curve. Okay, so probability density function for continuous random variable. For the discrete random variable the function is PMF, that is probability mass function. There is a result. In the case of, before that result there is a note. If f of x is a p.d.f of a random variable capital X, then the probability that a value of the random variable capital X will fall in some interval, open interval a comma b, is equal to the definite integral of the function f of x from a to b, that is p of a less than x less than b, which is equal to a to b f of x dx, or p of a less than or equal to x less than or equal to b, which is equal to integral a to b f of x dx. So what the note says that if suppose there is a particular interval, open interval, then the probability density function p of a less than x less than b or a less than or equal to x or less than or equal to b. In that case the distribution function, that is the p.d.f, is nothing but integral a to b f of x dx. This is what the note says. Then properties of p.d.f. The p.d.f f of x of a random variable capital X has the following properties. The property 1 is f of x greater than or equal to 0 such that minus infinity less than x less than infinity, and the second condition is minus infinity to plus infinity f of x dx equal to 1. These two conditions for p.d.f. Same manner we have discussed for PMF, that is in the case of discrete random variable. Okay, so properties of p.d.f is f of x greater than or equal to 0 and integral minus infinity to plus infinity f of x dx equal to 1. It's a very important property. Okay, now the result is result 1. In the case of discrete random variable, the probability at a point, here the point, if we want you can take it as x is equal to c. Okay, at a point, okay, at a point is not 0, but in the case of a continuous random variable x, the probability at a point is always 0. Okay, so in case of continuous, okay, its value is 0. In the case of the discrete random variable, at a point is not 0. It's a very important result. Okay, so how it is 0 at a continuous case means p of x equal to c, this is the point. Okay, so integral c to c, the point is c, we have taken f of x dx equal to integration of dx is x and the point is c. When you are applying the limit we are getting the answer as 0. That is the reason why we have written here. In the case of a continuous random variable, the probability at a point, here we have taken the point c, at a point is always 0. When it is 0 in continuous case. If it is discrete means the value is not 0. Okay, next the result 2. If x is a continuous random variable, then p of a less than or equal to x less than or equal to b, which is equal to p of a less than or equal to x less than b, and which is equal to p of a less than x less than or equal to b, and which is equal to p of a less than x less than b. This property is similar to the note we have discussed here. Okay, the same result only in the result 2. Okay, so p of a less than or equal to x less than or equal to b, which is equal to a less than or equal to x less than b, by the same manner which is equal to a less than x and which is equal to a less than x less than b. This result is in general. Okay, in general this result is not true for discrete random variable. So when it is true, this result is true for only continuous random variable. Okay, so this is what result 2 says. Okay, now we will see some problems under the probability density function. Look at the first question. Show that f of x is equal to x square by 3 such that minus 1 less than x less than 2, 0 otherwise is a p.d.f. p.d.f means probability density function. So how we are going to do the problem is, we have a property for p.d.f. What is the property for p.d.f? f of x is greater than or equal to 0 such that minus infinity less than x less than infinity, and integral minus infinity to plus infinity f of x dx equal to 1. If these two properties satisfies, then we can say that this f of x is a p.d.f. So in this question also we are going to check these two property, whether it satisfies the properties or not. If it is satisfies the properties, we can say that the given f of x is a p.d.f. Okay, so look at the solution. First we will take the given f of x. Here f of x is defined in the interval minus 1 to plus 1. It takes the value x square by 3, and remaining apart from this interval, remaining all the places the value is 0. So obviously f of x is, okay, greater than or equal to 0. Okay, greater than or equal to 0 in minus 1 less than x less than 2. It's given in the question, minus 1 less than x less than 2, f of x value is x square by 3. Okay, so obviously which is greater than or equal to 0. So according to the p.d.f condition, the first condition is satisfies. What is the first condition? F of x greater than or equal to 0. Now the second condition is integral minus infinity to plus infinity f of x dx equal to 1. If it is equal to 1, then only we can say that given f of x is a p.d.f. So we are going to check that whether it satisfies or not. So which is equal to, here minus infinity to plus infinity. But in the question, the function takes the value only in the interval minus 1 to 2, remaining all the places it takes the value 0. So how we are going to split this interval? So according to the definition, minus infinity to minus 1. Okay, minus infinity to minus 1 plus minus 1 to 2 plus 2 to infinity. Okay, 2 to infinity. The first one and the last one value is 0. It's given in the question. Only in minus 1 to 2 only it takes the value. So minus 1 to 2, integral minus 1 to 2. What is the f of x? F of x is x square by 3 into dx. Okay, f of x dx. So we can take the 1 by 3 outside. Integration of x square is x cube by 3. The limit minus 1 to 2. Again we can take the 1 by 3 outside. Already 1 by 3 is there. So 1 by 9 into 2 cube is 8. Okay, upper limit minus lower limit. Lower limit is minus 1. So minus into minus, this will become as plus. So we can get 9 by 9, which is equal to 1. So what is our p.d.f property? p.d.f property is f of x greater than or equal to 0 and integral minus infinity to plus infinity f of x dx equal to 1. Yes, we got the answer here. Minus infinity to plus infinity f of x dx equal to 1. Therefore, the given f of x is a p.d.f. So we can conclude like this. Therefore, given f of x is a p.d.f. So problems under the p.d.f like this only comes. Okay, look at the next question. If f of x is equal to x into e power minus x square by 2 such that x greater than 0, show that f of x is a p.d.f. 0 otherwise. Okay, so f of x is equal to x into e power minus x square by 2 when x greater than 0. So 0 to infinity f of x is greater than 0. So first condition, what is the first condition? F of x greater than or equal to 0. Obviously in this question f of x is greater than or equal to 0 when it is such that 0 to infinity. Okay, 0 to infinity, it's given f of x is equal to this one. So first condition is satisfied. What is the next condition? Next condition is integral minus infinity to plus infinity f of x dx should be equal to 1. If it is equal to 1, then we can say that given f of x is a p.d.f. Okay, so according to the question, we can split the interval minus infinity to 0 plus 0 to infinity. Okay, minus infinity to 0, the value of the function is 0. Only 0 to infinity, it takes the value x into e power minus x square by 2. So first integral value is 0. So for the second one, 0 to infinity, what is that? X into e power minus x square by 2 dx. Okay. Okay, now we are going to integrate this. See, function of this type, e power minus some terms like that, means we are going to integrate by substitution method. So what is the substitution? Put x square by 2 equal to t. Okay, so 1 by 2 into, differentiate this, 2x dx equal to dt. We can cancel this 2. So x dx equal to dt. Whenever we are giving the substitution, we have to check the limit also. When x equal to 0, when x equal to 0 implies x equal to 0, 0 by anything 0, so t equal to 0. Okay, when x equal to infinity, which implies t equal to infinity. Okay, so substituting that, integral 0 to infinity, new limit is also 0 to infinity, x dx is nothing but dt and e power minus t. Okay, e power minus, we have taken x square by 2 as t, so minus t, x dx is nothing but dt. Okay, integration of e power minus t, e power minus t integration is e power minus t by minus 1 with the limit 0 to infinity. Okay, so applying the upper limit minus e power minus infinity, and then the lower limit is already one minus is there, so plus e power minus 0. So this is the upper limit minus lower limit. E power minus infinity value is 0 plus e power minus 0 value is 1. So which is equal to 1. So therefore integral minus infinity to plus infinity f of x dx equal to 1. Okay, so second property is satisfied. Therefore given f of x is a p.d.f. So under the p.d.f, problems will come like this only. Okay, so what is the continuous random variable definition? What is the continuous random variable? Continuous random variable is a random variable only in the given interval. Okay, a random variable which takes all possible values in a given interval, that is called it as continuous random variable. Then probability density function. Properties of probability density function is f of x greater than or equal to 0 and integral minus into plus infinity f of x dx equal to 1. So based on that we have done two problems. Problems under this p.d.f will comes under 2 more questions. Okay, so next class we will see some other problems based on this. Okay, thank you for watching.